The U.S. Marine Corps is exploring a transformative approach to battlefield logistics with the deployment and testing of the Tactical Resupply Unmanned Air System, TRUAS, a heavy-lift cargo drone designed to deliver essential supplies directly to frontline units in remote or contested environments. Recent field exercises conducted by Combat Logistics Battalion 7 at the Marine Corps Air Ground Combat Center in 29 Palms, California, have tested the system under operationally demanding conditions, signaling a potential shift in how the U.S. military envisions sustainment operations in modern conflicts. The TRUAS represents not merely an incremental technological upgrade but a strategic innovation with the capacity to reshape tactical supply chains, reduce vulnerability, and enhance the operational reach of small, dispersed units. Developed by the British aerospace manufacturer Malloy Aeronautics Limited, the drone, commercially designated as the TRV-150, is part of a family of tactical unmanned aerial vehicles designed to address a long-standing challenge in military logistics: the ability to rapidly and securely resupply units operating in locations where traditional ground or manned air transport is impractical or hazardous. Under the Navarre PMA 263 program, the TRUAS reached initial operational capability in late 2024 and has since been integrated into Marine Corps trials to determine its effectiveness, resilience, and adaptability in real-world operational scenarios. Unlike conventional resupply methods, which often rely on large convoys vulnerable to ambushes or airlift missions constrained by air superiority and infrastructure, TRUAS provides a modular, autonomous, and flexible alternative, allowing commanders to deliver critical supplies directly to units on the move or positioned in isolated terrain. The operational concept behind TRUAS emphasizes autonomy and responsiveness. Equipped to carry pre-packaged payloads colloquially known as speed bags, the drone can transport ammunition, rations, medical supplies, and mission-essential equipment over distances of up to 20 kilometers while fully loaded. The Marine Corps variant, the TRV-150C, P4C, boasts a payload capacity of approximately 440 pounds, 200 kilograms, enabling it to sustain small units for extended operations without relying on conventional resupply chains. This capability is particularly relevant in distributed operations, a doctrine increasingly emphasized by the U.S. military to counter adversaries with sophisticated anti-access/area denial strategies. By ensuring that units in isolated or contested zones receive uninterrupted logistical support, TRUAS addresses both operational and tactical vulnerabilities, simultaneously preserving combat effectiveness and minimizing exposure to risk for personnel and manned assets. The strategic value of TRUAS extends beyond mere cargo delivery. In modern conflict environments, supply chains are often targeted as a means of undermining operational effectiveness. Enemy forces capable of disrupting convoys or aerial supply routes can degrade unit readiness, delay operations, and impose strategic costs disproportionate to the size of their forces. By employing autonomous drones capable of operating with minimal oversight and bypassing conventional choke points, the Marine Corps can mitigate these risks and maintain the continuity of supply. This approach reflects a broader shift toward unmanned systems in military logistics, where autonomy, reliability, and adaptability are increasingly critical in maintaining operational tempo and ensuring the survivability of forward-deployed units. The TRUAS platform is engineered not only for speed and payload capacity but also for versatility. Its modular design allows for rapid reconfiguration to suit a variety of missions beyond logistics, including casualty evacuation, reconnaissance support, and emergency relief operations. This flexibility underscores the broader trend within defense acquisition toward multi-role unmanned systems capable of providing operational support across multiple domains, reducing the logistical footprint, and enabling units to respond more dynamically to evolving battlefield conditions. By incorporating TRUAS into standard operations, the Marine Corps gains a tool that enhances both the tactical agility of individual units and the strategic resilience of its overall logistical network. Field testing at 29 Palms has highlighted several practical advantages of integrating TRUAS into marine operations. The system demonstrated reliability under high-tempo conditions and challenging terrain, confirming its ability to maintain continuous supply lines to forward-deployed units. Furthermore, the autonomous flight capabilities reduce the dependency on human operators in potentially dangerous areas, lowering risk to personnel and increasing the overall safety of resupply missions. These exercises also provided critical data for evaluating the operational limits of the system, informing potential improvements in range, payload capacity, and mission versatility. Such iterative testing is essential in transitioning unmanned systems from experimental tools to fully integrated components of military logistics. The introduction of TRUAS has implications for force structure and doctrinal development. As small unit operations become increasingly dispersed in response to threats such as improvised explosive devices, ambushes, or airspace denial, maintaining the flow of supplies becomes a complex challenge. Traditional logistical methods, while robust in conventional warfare, are less adaptable to the dynamic conditions of modern battlefields. Unmanned resupply systems like TRUAS allow for decentralized sustainment, giving commanders greater flexibility to deploy units across wide geographic areas without sacrificing operational endurance. This capacity to sustain distributed operations represents a potential paradigm shift, influencing not only how units are equipped and supplied but also how campaigns are planned and executed. Moreover, TRUAS embodies the convergence of emerging technologies in aerospace, autonomy, and military logistics. Its development aligns with broader defense trends emphasizing unmanned platforms, networked operations, and the leveraging of autonomous systems to reduce risk while enhancing efficiency. The TRV-150 series is described by its manufacturer as a workhorse solution, capable of performing multiple roles without extensive modification, a feature that increases its value in complex, fluid operational environments. For the Marine Corps, this translates into greater operational reach, faster response times, and reduced reliance on vulnerable or resource-intensive logistics chains, ultimately enhancing the resilience and effectiveness of forward-deployed forces. Beyond operational utility, the deployment of TRUAS also offers strategic signaling. By demonstrating advanced unmanned resupply capabilities, the Marine Corps signals both potential adversaries and allies that it is adapting to the evolving nature of warfare, where speed, precision, and technological advantage are decisive factors. The ability to sustain units autonomously in contested or denied areas presents a deterrent effect, as adversaries must account for the reduced effectiveness of traditional interdiction strategies. In essence, TRUAS not only improves operational capability but also contributes to shaping the strategic calculus of potential opponents, reinforcing the United States' commitment to maintaining technological and operational superiority on future battlefields. While TRUAS represents significant progress, challenges remain. Ensuring secure communications, reliable autonomous navigation in complex terrain, and integration with existing command and control networks are critical factors that will determine the system's long-term effectiveness. Additionally, questions regarding maintenance, logistical support for the drones themselves, and scalability in large-scale operations must be addressed before full operational deployment. Nonetheless, ongoing trials and iterative refinements suggest that these challenges are being actively managed, with each exercise providing valuable insights into system limitations, performance characteristics, and operational integration. Ultimately, the TRUAS program highlights a broader evolution in military logistics, where autonomy, flexibility, and survivability are paramount. By providing frontline units with the ability to receive critical supplies rapidly and safely, even in high-threat environments, the system enhances combat effectiveness while reducing reliance on vulnerable traditional resupply methods. Its adoption reflects a recognition that modern conflicts demand more than conventional logistical approaches; they require innovation, technological integration, and the ability to sustain distributed operations under conditions of uncertainty and risk. As the U.S. Marine Corps continues to refine and expand the operational use of TRUAS, the implications for tactical mobility, strategic planning, and battlefield resilience are profound, offering a glimpse into a future where unmanned systems are central to sustaining and enabling combat power. In conclusion, TRUAS represents a significant advancement in unmanned logistics technology, offering the Marine Corps a versatile and resilient solution to the challenges of modern warfare. By combining heavy-lift capabilities, modular payload options, and autonomous operation, the system enhances the ability of small units to operate effectively in dispersed, high-threat environments. Its deployment reflects not only a technological achievement but also an adaptive approach to operational strategy, emphasizing speed, safety, and sustainment in equal measure. As adversaries develop increasingly sophisticated means of disrupting supply chains, systems like TRUAS will be essential in ensuring that forces remain equipped, operational, and capable of responding decisively across diverse and contested battlefields.